purpose of a ground fault safety check is to determine that an inverter's ground fault detection hardware properly detects and indicates that its overcurrent protection breaker is in the open tripped state. A byproduct of this safety check also verifies there is no external fault between the normally grounded array conductors and the connected PV array to the system ground bus. This is otherwise known as the blind side ground fault. Should an inverter fail this important safety check, the entire system should not be worked on until the problem has been corrected and this check can be successfully completed. Because lethal DC and AC energy potentials exist inside the inverter with the inverter service disconnect switches in the open or the closed positions, this safety check should only be performed by electrically qualified service personnel outfitted with proper personal protective equipment. This presentation will demonstrate how to perform this check on the SGI XTM series inverter when the LCD display and LEDs are functional, and we'll also have a short presentation on how to conduct this safety check when the LEDs are not functional. Okay, so the first thing we've got to do is to stop the inverter from exporting power to the electrical grid. And we do this by pressing and holding the escape button on the LCD display. Press and hold the button for about 3 to 5 seconds and the inverter will stop exporting power to the grid. You should see on the LCD display PAC off. When it reads PAC off, you can go ahead and open the inverter's DC service disconnect switch. We're going to open the inverter AC service disconnect switch. On the inverter, we're going to wait for the indicator LEDs to go out. And they are. Open the enclosure door. On the left side of the inverter, find the ground fault breaker. Go ahead and set it to its open tripped position. Close the inverter enclosure doors. Close the inverter's DC service disconnect switch, and to close the inverter's AC service disconnect switch. Verify on the inverter that the ground fault LEDs are illuminated, and they are. This is what the inverter is supposed to do. If the inverter fails to do this, then it fails the safety check and no further work on the system should be performed until the condition is corrected and the ground fault LED illuminates as it is supposed to. All right, let's reset the inverter. Go ahead and open the DC service disconnect switch and open the inverter's AC service disconnect switch. We'll wait for the indicator LEDs to go cold, dark, and dead. And the display is out. Open the inverter enclosure door. On the left-hand side of the enclosure, go ahead and close the GFDI breaker. In cases where the indicator LEDs on the inverter are non-functional, we then have to verify the safety electrically using a digital multimeter set to measure DC volts. We have pre-set up a digital multimeter inside this inverter with one lead connected to the system ground bus and the other lead connected to the normally grounded array bus. And they're underneath the GFDI breaker. And the display is detachable from the meter, and we can see that LCD display right here. So in order to check this electrically, with the GFDI breaker in its closed reset position, the digital multimeter should read 0 volts DC, which it does. If we open the GFDI breaker, the digital multimeter will then read a DC voltage. Now, the magnitude of that DC voltage, we don't really care what it is, just that it's there. And it is. Go ahead and close the GFDI breaker. And we verify that that DC voltage has then gone back to 0 volts DC, which it has. This is electrically what this inverter is supposed to do. If the inverter fails to do this, then it fails this safety check and no further work on the system should be performed until this condition is corrected and the digital multimeter reads the DC voltage when that breaker is open as it is supposed to. So at this point, the testing is completed. Okay, Okay, so while this does not confirm that the detection circuit in the inverter is functional, it does confirm that there are no faults in the PV array wiring and that the inverter can otherwise be serviced without risk of DC electric shock. And that's the end of the presentation.